Welcome to homework.
Okay, so this is problem 24.25. In this problem, we have a single slit experiment. So we have a monochromatic light going through a single slit, and the wavelength of that monochromatic light is 558 nanometers, and the width of the single slit is 0.0348 millimeters. And we're going to observe a diffraction pattern on a screen that is 2.3 meters away from the slit. Okay, this distance r here. And the question is asking what will be the width of the central peak. Okay, so the width of the central peak will be this whole distance between the minima here and the minimum here. Okay, so we know that actually d sine theta for a central peak of a diffraction pattern is equal to lambda. Okay, and we can get sine theta will be just y here. What is I called y1 here? Okay, which is the distance between the center of the peak to the minima of the peak. Okay, over the hypotenuse here, right? But because the theta angle here is very small, so we can actually approximate the length of the hypotenuse here to be exactly the same as to be approximately the same the distance r here. So actually sine theta is just y1 over r. Okay, so we can substitute back here the sine theta. Oh, sorry. I want to substitute for sine theta actually. So d times y1 over r is equal to lambda, and hence y1 is r times lambda over d. But actually the question is not asking for y1, it's asking about the width of the central peak, which would be twice y1, right? Because this distance is y1 and this distance is y1 as well. So what we can call delta y, we can call the width of the central peak to be delta y, which is 2y1 will be 2 times r times lambda over d, and then we can substitute for everything here. So 2 times 2.3 meters times 5, 8 times 10 power minus 9 meters over d, which is 0.0348 times 10 power minus 3 meters, which will give us the width of the central peak, which is 7.38 times 10 power minus 2 meters. And this would be the width of the central peak. So the key part of this solution is that to realize actually to get the full width, we have to multiply y1 here by 2. And then all of the rest is just substitution into the central formula here, which is d sine theta is equal to lambda.